going to get into the part of geometry where we have to use logic and reasoning, and then we're going to have to get into some proofs and learn all kind of postulates and stuff. So we're going to start today with what we call conjectures and counterexamples. So the first sentence is starting off with two blanks, and those two blanks are inductive reasoning. Inductive, I-N-D, maybe I can write, U-C-T-I-V-E, inductive reasoning. Inductive reasoning. That is the process of reaching a conclusion based on a pattern of examples. So, for example, if you notice that I wear jeans on Fridays, then you can say, okay, well, this Friday I bet Miss Bridges is going to wear jeans because she's worn jeans every Friday so far, right? So we're basing it off of patterns and observations, things that you see all the time. Inductive reasoning, based off of patterns and observations. When you assume that an observed pattern will continue, you are applying inductive reasoning. You can use this inductive reasoning to make an educated guess. You've heard about that in science, right? Educated guesses. Yes, I'm looking. Yeah. All right, and you're making that educated guess based on known information and specific examples. So, for example, another one would be, let's see, I don't know, I'm trying to make something up. Let's say I noticed that Will wears a hat every day, so I'm going to assume that tomorrow Will's going to wear a hat. Or Ezra wears his glasses every day, so he's going to be wearing his glasses tomorrow, right? So things that you see and you observe. Okay. So what we are doing is we're making this educated guess, and the formal word for that is what we call a conjecture. Okay, C-O-N-J-E-C-T-U-R-E. It's written right above if you're not sure. Conjecture. So when I ask you to make a conjecture, I'm asking you to make an educated guess based off of patterns and observations. Now, some of us are really good with patterns, and some of us struggle a little bit. Like, sometimes I can get it just like that. Sometimes I have to look at it, stare at it for a minute to be able to figure out what that pattern is, okay? Am I ready? So, for that first example, it says, write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next term in the sequence. So, for example, the first one says appointment times. My first appointment time is at 8:30. My next appointment time is at 9:15. The next appointment time is at 10. The next one after that is at 10:45. So the first thing I have to do is figure out what is the pattern. Like, how far apart are these appointment times? Okay. 45 minutes. Okay, so that's my conjecture. Appointments are every 45 minutes. So I can jot that down. Every 45 minutes. And then it also asks me to determine the next appointment time. So if my last one was at 10:45, what's 45 minutes after that? Close. 11:30. So my next appointment time would be 11:30. Okay, so two parts to the answer. We had to first figure out what the pattern was, that these appointments were happening every 45 minutes. And then next figure out what the next pattern was, or the next appointment time was after. Does that make a little bit of sense? Okay. See if you can come up with the next one. It says, write a conjecture that describes the pattern in the sequence. Then use that conjecture to find the next term. You start with 1/2, then you go to 1, then you go to 2, then you go to 4. What are we doing to get from one term to the next? Don't say it out loud yet. I want everybody to have a chance to look at it and think about it. So write in words what you're doing to each term. And then tell me what you think the next term is going to be. 1/2 to 1 to 2 to 4. What do I do to 1/2 to get to 1? What do I do to 1 to get to 2? What do I do to 2 to get to 4? It has to be the same thing over and over again to be the conjecture for this pattern. Just that fraction is throwing us off, isn't it? Think about it going from 1 to 2 to 4. Jaden, what did you write on your paper? What did you write your conjecture was? Multiply by 2. If I go from 1/2 to 1, that's multiplying by 2. And if I go from 1 to 2, that's multiplying by 2. And if I go from 2 to 4, that's also multiplying by 2. So what would my next number be? Okay. I saw somebody else, I can't remember, somebody that had it written a different way but means something. Who wrote something different for your conjecture but basically the same concept? What'd you write? Adding the same number. So like 1/2 plus 1/2 gives you 1. 1 plus 1 is 2. 2 plus 2 is 4. Adding the same number is the same thing as doubling it, right? So we can explain it a little bit differently, and it means exactly the same thing. Does that make sense? Do you have any questions? Okay. Let's talk about the next one. I'm going to read it because there's nothing there for you to look at, right? Okay. So it says, make a conjecture about the sum of the squares of 2 consecutive natural numbers. There's a lot of words in there that we might not know what they are. Okay, let's start with natural numbers. Those are counting numbers. When you start counting, what do you start with? 1. Okay, so natural numbers are 1, 2, 3, 4, 5. They're whole numbers from 1 and above. The sum, what does it mean to find the sum of something? Add. And then of 2, or the squares, that means you take a number and multiply it by itself, of consecutive numbers. Consecutive numbers are next to each other. So let's just do a for example. Let's look at 1 squared plus 2 squared. Okay, 1 and 2 are consecutive numbers. And what I want to see is what happens when I square them and add them together. What kind of number do I get? Then I'm going to pick 2 different numbers, and I'm going to do the same thing. And I'm going to do this 3 or 4 times and see if I can come up with a pattern of what type of answer I'm going to get. So first of all, what's 1 squared? 1. And what's 2 squared? And what's 1 plus 4? Okay, so 5. What kind of number is 5? 5? I heard somebody say odd. All right, let's take a look at the next one. Let's do 3 and 4. So I'm going to do 3 squared plus 4 squared. Maybe. 3 and 4 are consecutive natural numbers. We're going to square them and add them together and see what kind of answer I get. What is 3 squared? What is 4 squared? And if I add 9 and 16, I get 25. Go ahead and try 5 and 6. Square 5, square 6, add those together, and let's see what kind of number you get there. Then hopefully we can make a guess off of that. Okay, we did 1 and 2. We did 3 and 4. Let's try 5 and 6, and let's see what we get with that. I got 5 for the first one. That's an odd number. I got 25 for the second one. Is that also odd? Okay. So hopefully, if this is going along the same lines, then maybe, or hopefully, the next answer is also going to be what kind of number? Odd. Let's check it and see. So 5 squared plus 6 squared. That's going to be 25 plus 36. Yeah. Sorry. So add those together, you get 61. Is 61 also an odd number? Yeah. So based off of these 3 examples that we did, what could we guess about the sum of the squares of consecutive numbers? What kind of numbers would it result in? Odd. Okay, so you would just write the answer is odd. Or something along those lines. Okay, so sometimes they don't give you things. So you will just have to like make some stuff up and do 3 or 4 trials to see what kind of answers you're getting. All right, so the next one is asking, is it possible for more than one conjecture to correctly describe a pattern? For example, the one that we did before, we said multiplying by 2, right? But we also said you could just say you're adding that same number, right? So we were able to describe it multiple ways. So I want you to look at that pattern there, 2, 4, 6, 8, 16, 32, and come up with a way to describe the pattern. And I want to see how many different ways we come up with. So just on your paper, just write down, describe what that pattern is. Go from 2 to 4 to 6 to 8 to 16 to 32. I want to see if we get a couple of different options there. What do you guys think? Go from 2 to 4 to 6 to 8 to 16, 32, you're multiplying by what? Multiplying by 2. Does everybody agree with that? Yes? Okay. I've got everybody staring at me. Multiply by 2?
So this started adding.
I wasn't even thinking about that, huh?
They started adding to and then
Started adding 2 and started multiplying by 2. Okay. Plus 2, plus 2, plus 2, plus... Oh, okay. What else did we say? Yeah. So you're adding to the first few, and then you start multiplying by 2. I get that. Go ahead. You're doubling it. But is 4 doubled equal to 6, then? And 6 doubled equal to 8? So it's not multiplying by 2. Anybody got any other ideas? What does it say? Let's highlight it so you can see. What does it say right there? 2 to the n power. So think about this. I want to show it here because I have more room to write. Yeah. This is the first number in my pattern, correct? This is the second, third, fourth, fifth, sixth, right? So what they're saying is 2 to the nth power. Which term it is my power. Does 2 to the first power equal 2? Okay. This is not working. Then 2 to the second power, that equals 4, right? But does 2 to the third power equal 6? Okay, so that's not right unless that 6 is not supposed to be there, which could also be. Hold on. Let me pause for a minute. Because you add 2, you add 2, you add 2, and then you start multiplying by 2. Hold on. You know what I think? I think that this paper is a typo, and I don't think that 6 is supposed to be there. Does that make more sense, though? I don't think that 6 is supposed to be there. So it would be multiplying by 2, yeah. Do you hear me? What did I just say? What did I say? The 6 should not be there, which means it would be multiplied by 2. Okay, so that's my bad not catching that before. That 6 should not be there. So if we had that 6 not there, then yes, we could say it would be multiplied by 2. Would it also work then if I switch those and put 8, 16, and 32? 2 to the third is 8, 2 to the fourth is 16. Yeah? Okay. So basically the short of that is, yes, there are multiple ways to describe a conjecture. Somebody can say multiplying by 2, somebody can say adding 2, or whatever it is, okay? The next one says, make a conjecture about the sum of 2 odd numbers. So pick 2 odd numbers and add them together. Then pick 2 more odd numbers and add them together. And then pick 2 more odd numbers. Do it 3 times. Just jot it down on your piece of paper right under that question. Pick 2 odd numbers and add them together and see what kind of number you get. Do it at least 3 times, and then you can make a conjecture from there. Make a conjecture about the sum of 2 odd numbers. Well, give me 2 odd numbers. 3 and 7. So if I add 3 and 7, that's going to give me 10. Okay. Detaj, give me 2 different odd numbers. Okay. 3 and 9. Okay. And if I add 3 and 9, I get 12. Alex, give me 2 more odd numbers. 7 and 9. And what does that give me? 16. So it seems for all 3 of these at least, and I'm sure some of you picked different numbers, what was the result when I added odd numbers together? What kind of number did I get? An even number. So the sum of 2 odd numbers is even. Okay, so again, you just pick some numbers that satisfy what they're describing, work it out, and try to see what is going to be the result there. Okay, and this last example before we get into our counterexamples, it says gas prices is this chart. The table shows the average price of gasoline in the United States for the years 2010 through 2018. Make a conjecture about the price of gas in 2019, meaning is it going to go higher, is it going to go lower? And then tell me why. And do you think it's going to be higher or lower than 2018? And then tell me why. Looking at the chart, in 2010 it was $2.84. In 2011 it was $3.58. In 2012 it's $3.68. 2013 it's $3.58. 2014 it's $3.44. 2015 it's $2.43. 2016 it's $2.14. 2017 it's $2.42. 2018 it's $2.84. So what did it do in the first 1, 2, 3, 4 years? Did it get higher or lower? It got higher, and then after that it started getting lower until 2016, and then it started doing what? Getting higher again. So what do we think 2019 is going to be? Probably higher based off of the pattern. You have 4 years of getting high, and then you have 1, 2, 3, 4 years of it dropping, and then only 2 years of increasing. So I would guess off of that pattern, it's probably going to increase again, okay? And just as long as you can support your reasoning, then you're good there. Is everybody good? Yeah. Okay. All right. At the bottom, to show that a conjecture is true for all cases, you must prove it. It only takes one example to contradict that and prove it false. Okay, it only takes one example to disprove or to contradict the conjecture. But to show that a conjecture is not always true, we want to give an example, and that is called a counterexample. Sorry, I'm trying to write it, but my pen is not working. A counterexample, that's missing. Okay, a counterexample can be a number, it can be words, it can be a picture. It can be anything that you can provide that will disprove a conjecture, that will prove it false. Okay, so the first one, it says find a counterexample to show that each conjecture is false. The first one, A, says if n is a real number. Real numbers are basically all of the numbers except for the imaginaries, which you don't even know about yet. So positive, negative, whole numbers, decimals, fractions, all of those are real numbers. So what this says is if n is a real number, then putting a negative in front of it makes it negative. I need one example to disprove that. What could n be that if I put a negative in front of it, it doesn't make it negative? I think I heard somebody say it. 0, because 0 is not a positive or negative number. So if I put a 0 in front of it, if I put a negative in front of it, it's still just 0, right? Okay. Another one would be, what if n were negative 1? If I put a negative, hold on, I'm going to show you. If I put a negative in front of that, what happens to it? It turns positive, okay? So you could choose any negative number as your n, or you could choose 0. Just because you give a counterexample doesn't mean there's only one correct answer. There are multiple correct answers. All right, for B, it says if angle ABC is congruent to angle DBE, then angle ABC and DBE are vertical angles. Do they have to be vertical in order to be congruent? No, right? So what I would do then is, I don't have a lot of room. I'm going to come over here to the side. Is I would just draw two angles and I would call them ABC. Okay, angle ABC. And I would draw, put like 50 degrees in there. I don't know, I'm making up a number. And then I would just draw again my other angle, DBE, and also call that 50 degrees. Are those two vertical? No. So did I just show you that there could be two angles that are the same, that are not vertical? Okay, you can do a picture, you can do a number, you can do words. Does yours have to look exactly like mine? No. I could have also drawn something else. Let me see. I could have drawn, just giving you options here. Okay, I could have drawn that and showing you that angle ABC and angle DBE are congruent, but they are not vertical, right? So multiple different ways you can disprove a statement. I want you to try that last one. If a line intersects a segment at its midpoint, then the line is perpendicular to a segment. Draw me a diagram to represent a counterexample. So draw me a segment, and then draw another segment that hits that one at its midpoint that's not perpendicular. That's all you have to do. Make sure you put your markings so that I know it's the midpoint. Should everybody's picture look the same?
No.
No. If a line intersects a segment at its midpoint, it's saying that it would have to be perpendicular. It's telling you to draw a picture of the counterexample. So first of all, we're going to draw a segment. You can call it whatever you want to call it, but I'm going to put its midpoint. What markings do I need to put to make sure I know that's the midpoint? The little lines, yeah. So I'm going to do that. And then all I have to do is draw some sort of line through that point in the middle that is not straight up and down perpendicular. It doesn't matter which direction it goes. Okay? It could look like that. It could go the opposite direction. It could be close to being right up, but you don't have your little right angle mark. So anything, as long as you have a segment with two congruent parts and a line going through that middle. That is my counterexample. Does that make a little bit of sense? So basically we're identifying patterns